Okay, so here's our next problem up for bids, the next truss. So if we look at this, the problem says, doesn't ask you to determine the forces in all the members. It says, find the force in, there's, add a few labels here. That's J, that's I, let's see, A, B, C, D, E, F, G, H. Okay, so find the force in FJE, so that's this one right here. We'll just put a little block across that, and FGF. All right. Now if we look at what this is coming straight down. These are going horizontally across. So if we sum forces, whatever here is there, what's there is going to be here. So I'll put little 2 dots here. So if we could look at, to answer this question, we could just look right down here at this joint and may be able to answer that. Now, the first thing we want to do before we start a problem is, the thing I like to do is say, are there any obvious zero force members? So I'm going to look for ZFMs. All right, so right away what I look at is, you got these guys up here. It's this big member, big member meeting out in the middle of nowhere. So this force is horizontal, this is vertical. Well, there's no way they could cancel each other out unless they're zero to begin with. So 0, 0. By the same token, 0, 0. So we can get rid of AB, BC, CD, and DE. All right. So that's case one, things meeting out in the middle of nowhere. And so then we had the case of if you have two things in a line or three members meet and there's no load. Well, that happens right here. Look at this. These two are horizontal. There's a vertical coming down. These two horizontals have no way of dealing with that vertical. Therefore, that vertical must be a zero force member. So we'll add that to the list, IH. But if this has 0, now we've created another situation. We have a line here and a line here. So these two can wipe each other out, but this one's oblique. If there's any force in here, there's nothing to zero it out. So therefore, this must have no force in it, so that doesn't happen. Well, that's IG. All right. And so let's see. We have a load here, stuff coming in. Here we have 1, 2, 3 pieces coming in. These are zeroed out. Load there doesn't matter. Load there doesn't matter. Here we have 1, 2, 3, 4. So everything else looks good. All right, so 1, 2, 3, 4, 5, 6 things are zero force members. Okay, that's generally the first thing that I would do on these things. The second thing that I do is I look for the supports and figure out the forces in them. Now, if you were to look at this thing and just leave all the forces inside the members, there's no external forces anywhere to this system that would produce a force in the X. Therefore, these supports will only counteract what they have to counteract, so that just means they'll just act in the Y. The external forces, the loads on them here in the Y, these will counteract that in the Y. There's nothing to generate anything outside of this system in the X. This can only be in the Y, and there's simply no forces generated, so there can be no X force there. So we don't have to worry about that. So if we're looking at this thing, what I really want to do is figure out what's going on right here. To get JE and GF, and GF and FE are the same thing. So if I could keep in mind, this has been zeroed out, this piece, so I just have this, this, and that. So if I knew the support at EY, I could easily sum forces in the Y, then some forces in the X, and I'd have this problem knocked out. So this is what matters. AY doesn't. So I'm going to sum the moments at A. That seems like the logical thing to do. So if I do that, the first load I have here is 6 kilonewtons. This is 3 feet. That must be 3 meters then. Let's see, are those kilonewtons? Just checking my units. Yep. All right, so that's 3 meters away. So that's going clockwise. So I have minus 6 times 3. Here's 6, and that's 4.5 out. So minus 6 times 4.5. And then E, I have pushing up. Obviously, it can't pull down because it's just a roller. Can't pull anything. So that's 3, 6 away, going like so. So that's plus EY times 6 equals 0. Well, solve for EY. We come up with 7.5 kilonewtons. And if you sum in the forces in the y, I will note that AY turns out to be 4.5 kilonewtons. Don't really care, but we know what it is. All right, so now what we need to do is just look at E. All right, we're not checking every single joint, and so since we're just looking at one section of the truss, this is called then, really deep name, the method of sections. All right, very deep stuff here, okay? So we're going to use the method of sections, which is just really looking at a single joint and figure out what's going on at E. All right. So here was what was left over after I did, bring this down, after I did all the zero force members. And now we're going to evaluate E. Joint E. And so EY, we figured that out. That was 7.5 kilonewtons. So we know that. So all we have to do now is evaluate what's happening in here. Okay, so we're going to actually go back to this for just a moment. And we're going to notice that this line here is 2 meters up, and going across was 3. So this is up 4 over 3. So let's just put that in right here. 4, 3. So that tells us our trigonometry. We can put that over here. 4, 3, and of course then the hypotenuse is 5. No problem. All right, so if we sum forces in the y, because this is just purely in the x, so that way I can figure things out. I got some force in the y equals 0. I got EY is 7.5 kilonewtons coming up. All right, and then I have minus FJE, and this will be minus 4/5. So multiply by 4/5. That'll give us the y component. Solve for FJE, and we come up with 9375 newtons, and it's in compression. Got a positive, and we had assumed it was compressing the pin. No problem. Well, now we can just sum forces in the x, and we'll get FFE. So summing forces in the x, setting that equal to 0, we get minus FFE plus FJE 3/5 would be the x component. We know that from that piece right there. Solving, FFE equals 5625 newtons. It's positive, so we have tension. And we'll note that FE is equal to FGF. By just, if we could sum forces in the x, that would show up there. And this problem, we were asked to find FJE, we got it. We were asked to find FGF, we got it. We said what was in compression and tension. Problem is solved. All right. Well, I'm going to set up for, we have 2 more to do, and then we'll be moving on to frames and machines. Bye for now.